Morning, good evening. Really nice to see everyone. Really warm welcome. So I'm just going to give it a couple more seconds. We do have a quite packed agenda today. As everyone is joining, once again, very warm welcome. And I'm Marcia Schofield. I'm a recruitment manager with Executive Diplomas and Specialist Masters at Said Business School. And today's masterclass is part of our Oxford Executive Diplomas experience. So I will kick off the session with a bit of an introduction to the Oxford Executive Diplomas, and then pass over to our guest today, Professor Teppo, to run the session on AI and strategy, what every decision maker needs to know. So I think some people are still joining, but I'm going to kick off. So we have 5 executive diplomas in our portfolio at Said Business School. And here you can see the academic directors and also the diplomas that we offer. So very briefly, we have a diploma in AI for business. That's our latest diploma. Has been very successful in the past 3 years. The diploma in financial strategy led by Ken Okamura, diploma in global business, diploma in organizational leadership. And I've got the diploma in strategy innovation twice here because we have an in-person stream that is led by Dr. Tim Galpin, and the online stream led by Professor Tom Lawrence. So these executive diplomas are master's level qualifications, and they are designed for experienced executives and professionals who are looking to get a specialist toolkit and knowledge in these specific areas. And actually, Teppo, our guest today, was leading on the diploma in strategy innovation diploma a couple of years ago. So yeah, it's great to have him back, and Teppo also teaches currently on the online diploma in strategy innovation as well. So very brief information about our diplomas. They are delivered in the part-time format, so they are designed for working professionals. You don't need to relocate to Oxford. You just need to commute to Oxford for 4 days for each module, if you choose to do the in-person option. And our diploma in strategy innovation online stream is delivered fully online, and it's 5-day per module option, and there are 4 modules on each diploma that you need to complete. These diplomas are master's level qualifications. They are accredited qualifications and accredited by the University of Oxford. The focus is very much on practicality of it, and there is a really a rigorous kind of focus on the academic research, but also how do you apply the learnings in real life in your own setting, in your own role. The start dates are from January to March next year, and the course fee for next year is £33,900. Very briefly, we do have scholarships in every cohort that are available every year. It's just a question that comes up a lot, so I thought I'd cover it. Scholarship application process is very competitive, and unfortunately it has closed for 2025, so we're not accepting any more scholarship applications. If you are looking to apply for one of our scholarships, it'll have to be for the 2026 cohort. However, if you are still looking to just join one of our diplomas next year, then you can apply until November, so still plenty of time there. Typical class profile, so we have, it does vary, so between 40 and 60 people in each class. Usually we have over 15 sectors represented, over 20 nationalities represented in each class. Our cohorts are very experienced, so average years, usually 15, 16 years of work experience, with around 5-10 work experience at a very senior level. Average age is about 40, 41, and we do have quite a high percentage of female representation in our programs. If you do decide to join us on one of our executive diplomas, you'll become part of the Oxford Business Alumni Network. It's a lifelong membership once you graduate, and you'll be part of the OBA community, which got over 24,000 members in over 150 countries. We've got 20 regional chapters, and it's the opportunity to get as much involved in kind of further activities as much as you want. You can become part of the chapter and lead a chapter or organize events, or just simply stay in touch with your community, with your chapter, and kind of take it from there. Our Oxford Executive Diplomas do lead to an Executive MBA if you wish to explore this path. The way it works is that the 4 modules that you complete in our diplomas can be, you'll be exempted from the coursework of these 4 modules if your application for the Executive MBA is successful, and you also get a fee reduction. So our Executive MBA is a 2-year part-time program. Unfortunately, the exemptions don't shorten that time, but this is something you can explore after the diploma. It's a very popular pathway. I'll quickly cover the application requirements as well. For our diplomas, you need to have at least 5 years of strong relevant work experience, undergraduate degree, and an English language proficiency. Luckily, you don't need to provide any GMAT. We don't hold any in-person interviews. As part of your online application, you just need to submit your CV, your academic transcript, 2 essays, and 2 references. And yeah, of course, if you come from a non-native English-speaking country, you also need to prove that your English is at the right level to study this program. And this is it from me. Sorry, I didn't mention that we do have a chat enabled, and please use the chat for any comments, any observations, and Q&A for questions today. So we'll keep an eye on it, and we'll try to answer as many questions as we can. But now I'm going to pass it over to Teppo to run his session. So thank you very much, Teppo.
Very good. Thank you, Marta. It's great to be with you. Marta's going to keep an eye on the questions. I think I'm just going to run through my presentation, but my plan is to leave time for answering questions as well. So you can feel free to add those into the chat or the Q&A function there, and then Marta will sort of point to some of them at the end, and we'll go from there. So again, my name's Teppo Feline. I'm thrilled to be involved with this little session here. As Marta mentioned, I was director of the Diploma in Strategy and Innovation. It was for 5 years, from 2016 to 2021, and I absolutely loved it. I mean, it's just a fantastic program. And I stay in touch through LinkedIn and various means with a bunch of cohorts and people who've become friends now. And it's really a fantastic program if you're looking to sort of renew your kind of knowledge base around strategy and innovation, and particularly around kind of hot topics like AI. And this is sort of I guess a kind of a taster lecture teaser for the types of things that you'd engage with. I'm covering AI and strategy, and I have an hour, so I'm only going to be able to touch on some things. But we'll go at it. So I should recognize my co-author, Matthias Hollweg. So Matthias is also at Oxford. He's a professor in operations. His background in machine learning. He started and runs the Oxford AI program, which has been a fantastic program, and is also involved with some of the diplomas, and is just a great scholar and consultant, and also even sort of practitioner within the domain of AI. He has an AI startup as well, along with being a professor. And so the sort of the origins of this project was a class that Matthias and I taught on AI. And we're both very interested in what does AI mean for decision making? What should anybody that's interested in making decisions, which is, we all make decisions in our lives. So I was just briefly mentioning that this is based on a class that Matthias and I put together, and there's sort of don't sort of look at these QR codes yet, but if you want additional information, there's sort of a long paper that tries to work through this logic and additional resources, including a kind of an Apple podcast and things like that, where I talk about some of this material. And so, okay. With that, so right now we're in this sort of exciting AI moment, and there's a lot of arguments about AI sort of surpassing human intelligence. And chess used to be kind of the fruit fly of intelligence, and a couple decades ago, essentially, humans or AI was able to beat humans in chess. But now we have things like checkers, Go, Jeopardy, Diplomacy, which is a relatively sophisticated game where you have to sort of infer intentions of others and so forth, where AI does remarkably well. And even in standardized tests like ACT, these are sort of college admissions tests or tests into law school. These are very kind of US specific, or bar exam, but other exams would be a good example as well. And areas like medical diagnosis, there's some areas of medicine where AI does better than humans in terms of diagnosis. It's still not like radiologists aren't out of business, even though that was sort of projected, but things are sort of moving rapidly in this domain. And the question is are we as decision makers going to be replaced? So many of you presumably work in organizations, you're entrepreneurs, you're executives. The question is, will AI replace us as human decision makers? And there's strong arguments by some, and not just kind of anybody. Daniel Kahneman, who sadly recently passed away, I think a couple months ago, and who's sort of just a genius of behavioral economics. But he had this interesting statement in 2018 as he was watching the trajectory of artificial intelligence. He says, this is the quote, it's a little bit longer, but I'll just read it out loud here. He said, will there be anything that is reserved for human beings, sort of, versus AI? And he says, frankly, I don't see any reason to set limits on what AI can do. And so it's very difficult to imagine that with sufficient data, this will be important in our conversation here, there will remain any things that only humans can do. You should replace humans by algorithms whenever possible. And when I read that, I thought that's a strong statement. So this is a statement made by Danny Kahneman in 2018. But the argument is that, and a lot of his career was focused on cognitive biases and things like that. And the argument is that, well, computers do a better job of processing information. That's what they're really good at. And humans aren't as good at that. And we'll come to what that means in terms of LLMs and things like that. And eventually, we're going to be replaced by algorithms. And Kahneman isn't the only one to say it. So I've sort of, in small print here, highlighted others. And some of these are really kind of top names in the field who've made similar arguments and published books around this and so forth. And here's sort of a smattering of books. Some of you may have read some of these already. Algorithms to Live By. Tom Griffiths is at Princeton, is a decision-making and cognitive scientist. Prediction machines here, AJ Agrawal, these are sort of economists writing in this space, but there's arguments being made that AI will essentially, it's better at prediction and humans aren't that good at it. And maybe we're going to be, replaced. And so that's what I'm going to address and think about. And I think that there's some key intuition that needs to be understood, particularly relative to LLMs, large language models, which is kind of the current state of the art with artificial intelligence. But this applies to other settings or forms of AI as well. But I'll get to that. And then Jeff Hinton, who's one of the kind of the fathers of artificial intelligence, sort of sub-symbolic processes specifically, so artificial neural networks, convolutional networks and so forth. I know we have a range of folks in the audience here, some with PhDs in computer science and others who maybe haven't engaged that much with artificial intelligence. So I'm trying to sort of steer down the middle, hopefully keep it engaging for both. But he makes a strong argument. This is a recent lecture. You can find it on YouTube, a lecture that he gave actually at Oxford as well. But here's a screenshot of the talk that he gave at Toronto. But he asked the question of, is artificial intelligence, is it smarter than biological intelligence? And his argument is yes. And not only will it be, but it already is. He argues that it mimics human consciousness and other types of things, if I remember right from the lecture. And so there's some strong arguments being made around this. And this has big implications for decision-making kind of writ large, but including us as in terms of living our lives, but also business decision making, entrepreneurs, executives, and so forth. So let me just cover at a high level just what it is that AI is. We could get into the weeds, and one of the QR codes that I had at the beginning and I'll have at the end definitely gets into the weeds of different types of AI, different types of machine learning and things like that. But I'm going to keep it at a relatively high level just for the purposes of this hour that we've got together here. But one way to summarize it is that AI is fundamentally a prediction technology. And so this is from the book, which is it's an excellent book. I mean, I disagree with some fundamental premises around it, but it's a great summary of AI in terms of what an executive or any decision maker should know from the book kind of called Prediction Means, but they say AI is a prediction technology. And this is important because Jan LeCun, who's another key figure within the domain of artificial neural networks, says that, prediction is the essence of intelligence. And I'm going to question that a little bit and think about, is it prediction that we always want in decision making, and prediction based on what, right? So if we think about large language models, what's the basis on which predictions are made? So how does an AI make a prediction, and what are we specifically talking about? So a lot of you may have used large language models like Claude or ChatGPT and other types of things. In that case, it's relatively mundane in the sense that it's predicting the next word. That's what it's good at, right? And so what the AI has is lots of data. In fact, trillions of data points, right? So it's scraped everything off the internet, Reddit conversations, Wikipedia, large libraries like Gutenberg, which are these archives of all the works of Shakespeare and all the public domain works. And it's taken that as its training data, right? And then lots of compute, so lots of computational power. And then it's trained with that, right? And if you think about that process, it's actually now down to weeks is my understanding. It used to be months, but down to weeks, that process of inputting, all this information and then it learning from that information on how to make predictions, right? And so in terms of some high-level specifics, this is a couple of these images are ones that I got from ChatGPT talking about my presentation, and so that was useful. But again, it's data and text from the internet. My understanding is that it's sort of in the kind of trillions of tokens. Just to put into perspective the the sheer scale of this, it would take a human 2 million years to encounter this amount of text. And in the paper that I've got a QR code for later on, we work through just the sheer amount of this information and how it compares to humans, right? And so this is an amount of information that your favorite, your favorite large language model has been trained with more information that you can never encounter, right? And that's part of the beauty of it. It sets some limitations, which I'll talk about it, but that's part of the beauty of it. But you couldn't encounter that amount of text as if you were to sort of read it or even speed read it in a lifetime, right? And so what the LLM, large language model, learns is statistical associations between these words. And so it's taking snippets, it's called a context window, and it's looking at the order, sequence, and context of how different words relate to each other, right? And it's remarkable at what it's doing there. And so this is obviously kind of the famous paper that launched the current AI moment in some sense. Obviously, AI goes back to the 1950s, a famous conference in 1958 in Dartmouth that had famous folks like Herbert Simon and McCarthy and Minsky and others attending. But a big breakthrough was this attention is all you need paper that was largely Google researchers that had this breakthrough with large language models. And what it's doing is it's predicting the next word. And it's important to note that this paper specifically was about translation. And so the question was, can a large language model, translation is a complex task. You have to understand lots of nuance. Any of you who speak multiple languages, I grew up in Finland, so I speak Finnish and also speak German. And so translating from one context to another isn't easy. Humans do that relatively well, and we have human translation. But for a long time, translation by machines was not as good as human translation until this sort of turn. It was decent, but with these sort of this transformer technology, you got a significant advance in terms of how this translation happened. But it's important to know this that what large language models can be thought about is as translation generalized. Okay, and so what is translation? It's the mirroring of one way of saying something, taking one way of saying a thing and matching it to another way of saying a thing, right? And I want you to keep that in mind as you're thinking about and using these technologies. I don't know, I have friends at University of Michigan, for example, who are having executives create business plans with large language models. And then they're having humans create business plans. And then they're having people independently assess, are the business models or business plans created by the large language model better than the ones by humans, right? And so this raises interesting questions about what is it able to do? Like, what are the boundaries of this? And so if you're trying to come up with a strategy for your company, for example, should you pop it into the large language model and what is it that you're getting, right? But what I want you to keep in mind is that it's taking one way of saying something. So think about it, saying something in Finnish, and now I'm going to say it in German or in whatever other language, right? So that's important, and it's great at that, right? So what can an LLM do? So again, it's about next word prediction. It's very good at that, based on its training data. Again, it's sampling stochastically from its training data to come up with what the next word is that should be said, right? And so it gives you fluid sentences. So it's stochastically drawing from this training data. I think that this fluency also, it makes us think that it's also intelligent. And I'm going to come back to that point, right? That it's doing something else than engaging in a statistical word exercise. And so I'm going to come back to that point because I think it's quite important. And if you think about its capability, I think one way to summarize, as Matthias and I were thinking about it, was it can write indefinite Wikipedia articles about subjects it has encountered. So that's what it's able to do. What is interesting is if you have expertise in a particular domain, you're hard pressed to actually learn something new. So if I read sort of in decision making or strategy a Wikipedia article, I'm hard pressed as an expert in that area, somebody who's publishing articles in that space, to learn anything new. Like, it's offering a great overview of things that we know Wikipedia is, and that's kind of the metaphor that I want you to think about when you're thinking about what the large language model is outputting, right? And so it might give you things that are new to you, right? But not to somebody who has expertise. And you've got expertise in some domain. And some of you, I'm guessing, have had experience with this in terms of how far you can push it in terms of the frontiers of knowledge, and, in some sense, right? And so it's not plagiarizing word for word what it's found out there, right? It's writing novel sentences, essentially summarizing knowledge in the sense of sets of, combinations of words that it's found around a particular topic, right? And that alone is remarkable, right? And so it's generative in the sense of new sentences, but I would argue not new knowledge. And there's some debate around this, but it has implications for how we think about decision making and strategy, which I'll highlight as well. In some sense, another way to summarize it, it's a fantastic memory engine. So it's encountered all these ways of saying things, and it's combinatorially sort of generating sentences out of that, and so it has a great memory of everything that it has encountered, and it's encountered lots of data, right? It's encountered lots of sentences, far more than we could encounter, like I mentioned, right? So that will come back to that point. So the question is, what does an LLM know then? So I've got a little bit of thought experiment here, and this is just to put this into a completely different context. But think of Galileo here. So let me first make this point. So truth for an LLM is a function of how frequently something has been said in the training data. This is really important. So the number of times pairs and orders of words have shown up that say something is critical for it in terms of what it outputs, right? And so the thought experiment I want you to think about, and I had to put it into a completely different context because we're in this AI moment and it's hard to think about it in sort of as things are playing out. So imagine this thought experiment. Say you had a large language model in 1633 when Galileo was alive, and it's been trained with all the written science to that point, right? So it's got everything. It's got all the writings of the great scientists that preceded it. Lots of text, right? And it's got Plato and Aristotle and et cetera, right? And textbooks in cosmology, et cetera, et cetera. So, and so we ask it about Galileo and his idea that the Earth revolves around the sun rather than vice versa. The question is, can the large language model somehow engage in some form of reasoning that would enable it to say that perhaps Galileo is right? And the fundamental limitation of a large language model is that its conception of truth is the number of times it's seen something being said. That's what it infers to be truth, right? And so it would absolutely say that Galileo is wrong, right? This is delusional. We have all this excellent data that shows that, and observations and so forth that shows that, the Earth clearly is at the center and the sun goes around, right? And they had perfectly good calculations that could make predictions with that information and so forth, right? And so I want to just highlight that as this sort of thought experiment to point out that it's using the frequency with which something has been said as a mechanism for saying what's true, right? Now, large language models, there's all kinds of new models, mixture of expert models and retrieval augmented generation, and different types of models that are trying to architect around this. And I'll touch on a few of those points, but fundamentally, that's a critical point, and it also highlights some of the issues around hallucination and things like that you may have countered or heard about. And so, the thought experiment is that at the time, the scientific consensus was the geocentric model was the right thing. Earth is stationary, so Galileo is wrong. All the scientific observations at the time said Earth is stationary. It could make very accurate predictions, even though they put Earth, the Earth at the center. They could make accurate predictions by looking at sort of these epicycles, right? And I've got an image of that here in a second that will highlight that, right? And so in even everyday data, you sort of walk outside and you're like, yeah, the sun comes up from over there and it goes around. It's sort of that, common sense almost seems to verify that, right? And so in the context of thinking about AI and prediction, in this context, what we needed was not more data. And if you know the kind of the current emphasis and kind of the zeitgeist and emphasis right now is more data will lead to better and better models, right? And that's what I want to push back on, is that we as humans aren't always looking for more data when we're making kind of predictions. We sometimes need the right theory, the right experiment, and the right data. Okay, and that's something that's very hard for the current large language models and other forms of AI to engage in, right? Because it's doing this straight up. We're going to just read as much data in and make inferences based on that past data, right? But how do we get to some form of forward-looking data? Again, there's some models that try to do that, but I'll talk about that. So AI limitations. So it's a mirror of its training data. It's a mirror of what it's been input with. Which is its great strength, but also its limitation, because it can't be forward-looking in any fashion, right? And any reasoning, this is important because people have actually done experiments with this. And think about how you might use it for business-related decision-making and so forth. Any reasoning is simply mimicking words associated with reasoning, right? So actually, there's been some really cool experiments where people gave it some famous reasoning tasks. There's something called the Monty Hall problem or missionaries and cannibals. I don't know. There's a bunch of sort of these various sort of famous decision-making kind of exercises and tests. And it turns out that if you slightly change the wording of those exercises, the large language model or AI gets completely confused, which highlights that it's actually not kind of reasoning of itself. It's just mimicking the reasons that people give for decisions. And that's a really important point to make, because if you're trying to use it for something that's kind of forward looking, it's not going to be the right tool for that. And I'll touch on what that means, right? So it's a stochastic engine for producing text, and it's excellent at doing that. By the way, you shouldn't take, and none of you will do this, but don't take this for gospel. Like, there's people who strongly disagree with this, that these limitations will within months be sort of overcome with new types of models and so forth, right? But Matthias and Matthias in particular, he runs this AI program in Oxford. He stays at the very cusp of this research, and as of now, there's very little that can sort of go beyond this issue of kind of mirroring and mimicking, which can be very useful for different things, but not for some of the things that people are using it currently. And so it's a system of prediction based on past data. But the question is, when the past data isn't useful for some kind of forward-looking decision, what do you do, right? How do we come up with new data, right? And so that's something where humans have a remarkable capacity in terms of their cognition to engage in that. And in some ways, I'm trying to kind of challenge the false equivalence that's put between what an AI is doing in terms of its cognition. And actually, a lot of the language around neural networks comes from how people think about the human brain. But our argument would be that, there's something different going on here than there is with large language models or other forms of AI that are using past data to make future predictions. Of course, we do that in some fashion as well. But there's something generative or different that goes on as well, which I'll touch on here as well. And so you can't reason beyond what's encountered in the training data. So I don't know. Here's just a picture of the old kind of geocentric view of the universe, and you could kind of make good predictions by kind of mapping the trajectories of different planets. And of course, Galileo's model is a much simpler model, but the data from this will not get you to that, right? You need some mechanism of sort of questioning this data, and that's what I'm going to get to here as well. So just to offer this contrast a little bit more sharply, so if we think about a large language model and humans in terms of, say, its training data or how it learns, like I mentioned, 13 trillion tokens with the latest models, lots of different lots of parameters, the weights and the statistical associations between the words and the context windows, versus a human. We looked into this research. We humans, we encounter something like 17K words per day. Say, a child hears parents or caregivers talk to them. They passively might hear, a radio or whatever. And so at 17K words a day, it would, again, like I mentioned, it would take a long time for us to encounter all these words. So what's the LLM good at? It's fantastic at next word prediction, fluid text, backward looking, Wikipedia level knowledge. Here's the mystery, right? This is so how is it that humans bootstrap knowledge and information with this far sparser sort of data set in some sense, right? Like far sparser data set. And it turns out that humans can engage in this generative speech and true novelty and forward-looking theorizing, which is what a large language model can't do. Again, some of you might push back on this, and again, Marta's looking at questions, and she'll try to sort of find them at the end there. And then, like I said, I've got a link for the paper at the end as well, where we go through. It's a very long 50-page paper where we go through lengths to sort of work through this logic. But anyway, so we'll get to that. Okay, so I want to highlight what's going on then with humans versus in terms of prediction that's different than what's going on with a large language model or any form of AI. And so the example that I want to give is I want to give just a very specific context. So this is an actual picture, and that's why it's grainy, from 1903. And this is a famous experiment that a scientist called Samuel Langley did on the river in Washington, D.C. with dozens, hundreds of people lining the river to watch as he launched this aircraft into the sky, and he was going to fly. So he got lots of resources from the US government to try to create what was called heavier than air flight. And this is Samuel Langley in 1903, and he came off this ramp and he dove straight into the ground, into the water. Okay, and he did this twice. I think over a couple days. And basically, all these scientists are watching this. New York Times is there. I'll have a quote from them as well. And they say, listen, like the prediction here has been wrong. Like people think that we can fly, but it's not possible. Samuel Langley just highlighted that this is problematic. Humans just aren't meant to fly. We don't have feathers, and I don't know. There's all these issues, right? And so think about the prediction for something. In this case, something like making a prediction about whether humans can fly or engage in what was called heavier than air flight. So in some kind of machine or powered machine. And the top minds at the time, you can imagine an LLM being input with all this information. And so Lord Kelvin, for example, he was the president of the Royal Society. He said, and probably the top physicist, of the time, of the late 1800s, I state flatly that heavier than air flying machines are impossible. And so he said, there's just no physical materials where you can do this. It's not possible. And Simon Newcomb, who was a famous astronomer and physicist mathematician, said that flight by machines is heavier than air, is impractical and insignificant, if not and utterly impossible. And he says, yeah, sure, birds fly and insects fly, but it's not going to happen for humans. So here's a kind of a prediction, and I don't have the exact quote here. It's in the paper, but once the New York Times folks observed this, in 1903, they said that maybe in like 1 to 10 million years we'll do this. Right now, I want you to note the year. This is 1903, right? So a couple months later, the Wright brothers actually did fly, right? And I'm going to talk about like, what is it that's going on there? You've got this, in this case, it was two bicycle mechanics who have this very, in some, anti-scientific conception, at least based on the current consensus, that flight might be possible. So they have this belief, right? And all this data that's coming their way of Samuel Langley not being able to fly. There's a guy named Otto Lilienthal, who was a famous pioneer in Germany. He actually died flying. So all this data says like this is not possible, but nonetheless, these two have this sort of belief. And actually there was just to sort of highlight and make a fine point here. Famously, a lot of people say, "Oh yeah, what about birds?" And there's a UC Berkeley professor at the time who became very prominent, and he did this analysis of birds, and he looked at all birds, large birds and small birds, and he arrayed them, and he said flight stops at a certain weight. It's about like 50 pounds, okay, 25 kilograms or something like that. After that, we don't fly. Therefore, humans can't fly. And that was his data. That was the data that he used, and he published this article in a prominent outlet. And there's no data or evidence to support the plausibility of flight. Right now, the contrast that I'm trying to highlight here is that, again, with large language models and AI, we've got data-driven prediction, and that's great in stable environments. But there's something else that humans are doing, particularly in the context of strategy, that's actually ignoring data like that, and that's kind of the cardinal sin in some sense. Like, you wouldn't want to ignore scientific consensus and so forth, but the forefront of knowledge, and I think this would go the forefront of trying to create new economic value. In some sense, you are ignoring some data because you have a belief that certain experiments will create the right data. That's the key link, right? So just to go through this prediction here: is human flight possible? Scientific consensus is not possible. Scientific data says not possible. Experiments say not possible. Large language model not possible. So what's interesting here is this isn't just a naive belief on the part of these two. So I actually went through a bunch of archival documentation because they corresponded with lots of scientists and so forth, and they sort of embarrassingly said, yeah, well, we still think flight is possible. We're sorry. This sounds delusional, is the language that they used. But what they were trying to do is, we think that flight is possible if we engage in trying to solve specific problems, and they narrowed it down to 3 problems. We need to solve lift, propulsion, and steering. And so they weren't looking for data disconfirmed. They're looking for experiments, trying to create the right data and engineer the right solutions in order to create something that doesn't exist currently, right? That's the difference between data-driven prediction versus something that human cognition engages in. And I'll make a finer point of that here in a second, right? And that's a critical difference, particularly when it comes to novel strategic decision-making as well, right? And so they were trying to develop this theory of flying, sort of ignoring existing data in some sense, right? In fact, they used bird data, but they were interested much more in sort of the pitch of the wing and the shape of the wing, not in feathers per se. They're looking at a completely different aspects of that data, right? And that's what large language models, any form of AI computation is not able to do. There's something famously coined by McCarthy and Hayes called the frame problem, and that for any computer scientists that are on this call, that's the issue here. And so, all right, so here's a famous sort of image of kind of liftoff here of them flying. So what is it that humans are doing? So humans are engaging in some kind of forward-looking reasoning, and just to give you some kind of context from different settings. And so there's in evolutionary theory, and I've worked with an evolutionary biologist called Stuart Kaufman, and we kind of looked at this building on work of Liebenberg and others. Things like hunting are a process of kind of data gathering in the strict sense of processing lots of data, but finding the right clues. or having a theory, right? And this also comes through in areas like developmental psychology in terms of what babies know. So babies aren't a function of all the inputs. They're actually experimenting with their world and surroundings. And that's what I would argue any decision maker or executive is also doing. And we've got sort of a formalized process for how to think about that. I've got a link to an article that talks about that, but that's what's happening there. And so there's been a lot of talk about sort of just trying to throw out theories, just use data. But I really like this quote that says there's nothing as practical as a good theory. And so what the Wright brothers had was a theory of what it will take to get sort of liftoff, right? And the specific problems that they needed to solve in order to accomplish that, right? And these theories are critical and shouldn't be thrown out. You know, I got to use a quote by Einstein here. So he says, whether you can observe a thing or not depends on the theory which you use. It's the theory which decides what can be observed. And I'd argue that you as executives, us as decision makers also have theories rattling in our heads that direct our attention towards certain types of problems that we need to solve and so forth. So let me bring this down to, you know, to a kind of an economic context or strategy or innovation related context. And so think about inputting something like an idea for Airbnb in say 2000 into a large language model, which is predicting based on past data, right? And so Airbnb, when they were pitching their idea, top venture capitalists, somebody called Fred Wilson, he actually famously sort of published his emails around this exchange. Airbnb pitched their idea to Fred Wilson. He invested in Twitter, Kickstarter, and so forth. And Fred Wilson said, this is only for couch surfers and hippies. And hotel experts said, this isn't a viable business. Why would we do this? And Fred Wilson said, we're not going to invest, right? So this isn't possible. And if you'd asked me in, I don't know, around, I think it was founded around then, 2007, would I rent my home here to a stranger flying, you know, would I rent my home in Oxford to somebody flying in from Finland or from Pakistan or Japan or wherever? I'd say no. Like I'd be, you know, you don't rent to strangers. Like that, you know, home is sort of a sacred space. You don't have strangers coming in. Or when I travel to Milan or wherever, I won't stay at strangers. It turns out now, actually, I mostly just stay in Airbnbs because it solves, you know, big problem. Usually I'm traveling with my daughters and family, and we don't have to get several rooms and so forth. But if you'd asked me, I would said, and I worked in venture capital for several years, and I like to think that I'm at the forefront of sort of creatively think about how to create value and so forth. But if I'm honest, I probably would have said no as well, right? And so there's no evidence in data in some sense that this is possible. You can imagine you could do a bigger survey, not just ask one person, me, but you know, and so forth. But in their case, they said, well, and think of this a la similar to the Wright brothers. If we can solve specific problems, in this case, it was trust, matching people, being able to find those wanting to rent and those renting, and then transaction escrow so that people don't, you know, if they trash your house, that there's some remediation. You could, you know, you have a credit card through an independent party or through the platform. And so now it becomes a reality that it is possible, right? And they've generated in this process sort of, you know, data that previously didn't exist, right? And so data-driven prediction is only as good as the data, and most of the time we only have past data, right? So the question is, can we get our eyes on future data and new ways of seeing things? And so now, again, we have a company with, you know, $100 billion plus valuation. I think in the interest of time, I'm going to skip through just the Xerox PARC example. I've got here in this article here, and you can go to this later, and it's open access, several examples like this of different types of companies who use this type of Wright brothers type of logic that you can't engineer with AI. And believe me, we've tried, right? So I'm actually worked with several people who are PhDs in this space, in neural networks and so forth, and trying to sort of get forward-looking novel statements beyond things that they've encountered in the training data, the LLMs, is extremely hard versus this is something that humans can do and do, right? And so what we do is we're creating data and we're intervening in the world through experimentation, right? We've developed sort of a process around this. Those of you who will be in one of the diplomas will get more around this type of thing. So to get to kind of the upshot, maybe implicit question in all of this, should we replace human decision makers with AI? I say no. Maybe for some of you that's obvious. Other people, Daniel Kahneman, again, somebody who's Nobel Prize winning a scientist, says yes, and eventually we will. The contrast that I've tried to highlight is that when past data works for making predictions about the future in routine, stable types of environments, that's great, right? But in situations where that's not the case, that's where human cognition is stellar, right? So that's important. So the risk with AI and decision making, let me just highlight a couple. In a program like the diploma program, almost any of them at this stage were all reacting to and thinking about how AI implicates decision making, whether you do the leadership one or the artificial intelligence one or the one in strategy and innovation. The risk with AI is just quickly, one of them is this is actually a longer story about how technology is used more generally. But Eric Brynjolfsson, who's at Stanford, has this longstanding research on this IT productivity paradox, which is we make huge investments in IT, but we don't see the return. Where is the return is the question with IT. So the winners are the people selling the IT or the AI or the solutions, right? And so where are the returns? And people have made arguments, including Brynjolfsson, that AI is different, right? And it's not to say you can't see returns, but on average, people don't get returns. Like we spend a lot of resources on these technologies, but the question is, how will you specifically use it differently from others, right? Like it's sort of this differential calculus, right? And so it's important as decision makers use and look at these tools to think about, okay, let's not fall for this paradox. How will we specifically use it? And it's critical to understand. That's why I've tried to kind of highlight at a fundamental level that the risk is that we don't understand what it can and can't do. And some of that is an evolving thing, right? We're playing around with the tools and so forth. But I think that the ways in which people are trying to use it now to sort of kind of shoehorn decision making into it, particularly strategy and so forth, that's not the right use for it. And maybe a broader point, you think about something like Claude or ChatGPT by OpenAI. These are generic technologies, and they result in generic outputs, right? Think about what it's been input with. It's been input with all this text, from humanity, but it's nothing specific, right? And the more that you can make it specific to your company, right? And so now there are some tools, like I mentioned briefly, retrieval augmented generation and so forth, that use the general language capability, but then retrieve information specifically from documents that you might have in your company or that you might point it towards. Those are potential exciting developments, but we're still kind of early stages there. And so in terms of opportunities rather than just risks. So previously I was talking about risks, opportunities. I think that, and Matthias Hollweg, who's my co-author on this kind of research program, has written several pieces on, like, for routine operational decision making, again, where the past maps the future. Fantastic. Like there's lots of really cool applications and opportunities there. And in the paper, we point to a lot of those. I mentioned this idea of kind of firm-specific application, and so in terms of technology, these retrieval augmented generation is one direction. But a more broader point that I want to highlight is that what you want to do is think about what are the unique problems that we're trying to solve, and is AI one variable in how we do that, and how do we need to customize in order to do that, right? What do we need to customize and make firm specific, to use kind of economic language, in order for us to get the best mileage out of it? And the more you do that, the better, because there's going to be lots of general application of this, but I think that's going to be a waste of resources rather than the specific application. And that requires more careful thought about what is, more broadly your company's strategy. And a lot of the Oxford programs are all focused on that, trying to figure out, how is it that the system of things and with your company kind of there, how do you orchestrate and create value with stakeholders and technologies and so forth all together? And there'll be lots of opportunities in the paper. Again, you can kind of download it. There's lots of kind of AI or human AI hybrid decision-making solutions that are emerging, and you might look at some of that as well. That's just a sort of a brief primer. I wanted to leave a couple minutes for questions, and I've got sort of a note here. If you have hard questions, email Matthias. There's his email address. That's not fair, but I'm passionate about this topic and actively engaging on it. So if you're on social media, LinkedIn, and other places, I'd love to connect those types of places as well. Matthias, I'm sure as well. Here's just sort of QR codes for the different papers. So I covered some intuition from this AI paper that you can get there. There's a podcast that I did with Russ Roberts, who's at the Hoover Institution at Stanford, around these issues. That's a link to the Apple podcast. And then a framework for specifically thinking about how is it that we uniquely create value, because I think that is central for you as a decision maker or an executive. And this goes for any technology. Blockchain, several years ago, I was involved with a blockchain strategy class that we did online for Oxford, and being it's great to be excited about these technologies, but thinking about the specific applications relative to you is where the value is. And so with that, I think I'm going to end and stop sharing screen. And I don't know if there's a question or two that this will be made available, is my understanding, if you want to look at the slides again or click on those QR codes or whatever. But were there any questions in there, Marta, that popped out and that I can address immediately?
Yeah, absolutely. Thank you so much, Teppo. There's been so much engagement in the chat, both about the session and our diplomas, which is great. So one question was from Bruno, and he was asking, so when you were talking about text prediction and LLM, so he was asking, what about AI models learning from images? Does it work? And how will this accelerate the quality of AI?
Yeah, so there's lots of kind of multimodal learning of AI that includes, visual types of data. Even people are looking at haptic, touch, those types of data, hearing, other types of things. So those multimodalities are important. And Ilya Sutskever, who is one of the key players, used to be at OpenAI, now started this Safe AI initiative, was an early player in this space of images, right? What's important is the technology there's the same, right? So it's still using neural networks, and the inputs are, trillions of pixels and of images and data points, right? And when it's creating something out of that, like it does say with when you use DALL-E or some of these other tools, it's engaging in a combinatorial exercise based on things that it's seen in the past. And again, that can create lots of interesting things, right? But there's something else that humans are fundamentally doing, and so I still want to sort of highlight that's really important. But certainly those multimodal types of models, where it's both visual, textual, and other types of information, those are exciting, and there'll be new developments there. I'm kind of team human, and I still think that there's a unique aspect to what humans are doing, and so I've touched on several things that relate to that. So that's a great question, though. Yeah. Any others?
Thank you very much. There's a question from Veronique. I'm hoping I'm pronouncing it right. How AI can replace emotions, experience, and cultural aspects of life when it comes to taking decisions?
I know this is a great question. I was just at a conference at Harvard Business School, and we were talking a lot about this. It's a hard question because, and it actually showed up even in the data that I was looking at with Wilbur and Orwell, right? Like they're very passionate about flight, right? How do you capture passion, right? And this passion went against the data, right? And so AI is very good at taking data dispassionately in some sense, right? But that human aspect of it is really important. And I'm actually a big I really like the psychologist William James. He's kind of one of the early psychologists, and for him, things like kind of belief and passion are central. Those sound like very vacuous words to kind of my scientific mind, but it turns out that they're really critical for engaging and motivating our problem solving, right? And in some ways, we've taken that motivation out of artificial intelligence, so it's not there, and people are trying to shoehorn it and put it in different ways. But I do think that that's a unique human aspect as well, and so that's a great point to raise. We touch on, if you happen to look at the paper, we touch on some aspects of that because I think it's an important one. So that's a great question. question. And like I said, more generally, I'm sure there's other questions. I don't even have time to go into the chat, and I'm seeing there's lots of questions and things popping up. So I try to engage on Twitter, or I guess what is now on X, on LinkedIn and other venues around these questions actively. And so click there and link up with me, and I'm happy to engage this conversation further. And hopefully you're in maybe one of the sessions or modules that I teach in the future, because there's lots to sort of double click on here and sort of go down a rabbit hole, because I've given you an hour of things, but there's including technical detail, right? And so hopefully you got a rough sense of some key things there. So yeah.
That's brilliant, Teppo. Thank you so much. Yeah, as you say, we've had so many questions. So we are coming to an end of the session, and I do encourage everyone, to reach out to Teppo and have a look at the QR codes that he shared as well. I've got one last thing, and actually it's really useful because, as I say, there has been a lot of interest in our programs as well. So if you do have any questions at all about our diplomas, you've got contact details of my colleagues here. So both Joe and Magda oversee recruitment for the diploma in artificial intelligence for business and diploma in global business. Joe is about to go on paternity leave. Congratulations, Joe. So please reach out to Magda in the next couple of weeks, and hopefully then you'll be able to meet Joe as well. My colleague Pagan looks after the diploma in financial strategy. My colleague Hannah Gelder after the organizational leadership, and myself after the diploma in strategy innovation. So you've got our details here. Get in touch as well if you have any specific questions. And last but not least, in August, we also have another event. If you are looking to join our diploma and you'd like to get more information about funding, and especially how to secure funding with the organization, please join our webinar on the 22nd of August at 12 o'clock UK time. My colleague Magda will be hosting it. You've got a QR code here, so you can go and just register for it. And otherwise, I think, yes, we're running out of time now. So thank you so much for everyone who joined today. It's been great. Thank you so much for all the engagement. And we're hoping to see you in future events as well, and hopefully in one of our diplomas next year as well. Thank you very much, Teppo, to you as well. And yeah, we'll see each other hopefully very soon. Have a good day, everyone.